Okay, so we're going to go over special angles for triangles. And question number 5, is it? 5 wants us to prove this statement here. Sine squared theta plus cos squared theta is equal to 1 using exact values for these things. So what they've given us is theta is equal to 30. Okay. So what they want is sine squared 30, or sine 30 squared, plus cos squared 30 is equal to 1. So in other words, we have to find out what sine 30 is as a fraction. Okay, so when we draw up our special triangle here, we have two major ones we're going to talk about. And this one here is a little more equal. Okay, so we have one special triangle that is 45 degrees, 90 degrees, 45 degrees. And it is measured 1, 1, root 2. Our other one is 90 degrees, 60 degrees, and 30 degrees, and it is measurement of 2, 1, and root 3. Okay? So, they want us to set up our SOHCAHTOA using these special triangles. So in other words, sine 30, and sine being opposite over hypotenuse, if we have this 30-degree angle, opposite over hypotenuse is just 1 over 2 for sine 30. So we're left here with 1 over 2 squared plus cos 30. Cos is adjacent over hypotenuse, which is root 3 over 2 squared is equal to 1. Okay, so we need to work this out. Well, 1/2 times 1/2 is going to give us 1/4 plus, and in this case, root 3 squared, do you know what that's going to be? Do you know how I got 1/4 from 1/2? Let's work it out. So what that means is 1/2 times 1/2. And in this case, this means root 3 over 2 times root 3 over 2 is equal to 1. We're just trying to prove this now. Now when we multiply fractions, we do the top by the top and the bottom by the bottom. So 1 times 1 is still going to be 1. 2 times 2 is going to give us our 4. And this one, root 3 times root 3. Do you know what it'll be?
3?
Yeah, it's just going to be 3. The roots kind of drop off. And 2 by 2 is going to be, so 1/4 plus 1/3, sorry, 1/4 plus 3/4 is equal to 1/3, or in other words, 1 is equal to 1. So we've proven this by putting in the exact values and squaring them. Okay, so this is a little proof you're going to get into later. They just want you to go about actually proving it. This is something you'll have to memorize. Sine squared theta plus cos squared theta is equal to 1. And they want you to just prove it in many different ways. So we've done it with question A there. Okay, next example. They've given us another proof. Sine theta over cos theta is equal to tan theta. And they want us to prove this for 30 degrees, or when 30 is equal to theta. So essentially what this is sine theta is equal to cos theta. Sorry, let's not write theta. I've already written that in. Sine 30 over cos 30 is equal to tangent 30. So cosine 30, cos 30 equals tangent 30. Okay, I'm actually going to write those values in here. Sine 30, and what we'll do is we'll actually write it in colors for you too. So sine 30, which is our 30-degree angle here, is opposite over hypotenuse, right? Opposite over hypotenuse is 1 over 2. So we got that. Next one is cos 30, which is adjacent over hypotenuse, which is root 3 over 2. So we got that. And finally, tangent 30 is equal to opposite over adjacent, which is 1 over root 3. Okay. So all those funny looking colors in there is exactly how we got these numbers. So we're going to replace all of those with our numbers here. So we get 1 over 2 divided by n equal 2 divided by root 3 over 2 make some room. Root 3 over 2 is equal to 1 over root 3. Okay. Now, I have a fraction I have two fractions in fraction form. It can be a little hard to recognize. So what does this symbol mean? Divided by. So let's go 1/2 divided by root 3 over 2 is equal to apparently root 3. We need to prove this. So I'm going to prove the left side of the equation. This is the right side. So I'm going to leave the right side the same and just focus on the left. Now, when we're doing division, you actually turn it into a multiplication question and you flip the second fraction. So we're going to turn it around. So now this becomes 1 over, and we multiply 2 over root 3. Okay. Well, when we go to multiply that, that's going to become 1 over 2. Okay. So we get, sorry, not 1 over 2. 1 times 2 is 2. 2 times root 3 is just 2 root 3. We're not going to go combining that, right? Is equal to right side. Equal to right side. And then let's reduce this fraction. Well, I have two 2's, right? So they create a 1, or a lot of people call them canceling out, but what's happening is they create a 1. So we have 1 over root 3, which is exactly what our right side was in the beginning of this question. Does that make sense? Yeah. So all, again, is just working with our fractions in order to prove something.